Hello, my name is Jacob Murky, and this is my demonstration for my ECE 542 final project prototype. This prototype implements a simple closed-loop feedback control system structure in which the measured temperature from this sensor is taken and compared with the desired temperature provided by the user. Any error in which the measured temperature is greater than the desired temperature would result in the generation of a duty cycle that would control a fan that would cool the environment and reduce the error. Since the fans I wanted to use demanded too much current, I have elected to use these 4 LEDs on the left to represent what level the duty cycle for the fan would be based on the error. Each LED corresponds to a range of 25% since there are 4 of them. So the blue LED corresponds to a range of 0 to 25% for the duty cycle, the green LED a range of 25 to 50%, the yellow LED a range of 50 to 75%, and the red LED a range of 75 to 100%. In terms of what numbers determine the duty cycle, I've made it a design standard that any error greater than 5 degrees would result in a 100% duty cycle, and any value or error in between that range of 0 degrees to 5 degrees would determine the actual duty cycle that's not 100%. So, in terms of degrees, that means that the blue LED corresponds to a range of 0 to 1.25 degrees error. The green LED will turn on if the error is in between 1.25 to 2.5 degrees. The yellow LED will turn on if the error is in between 2.5 to 3.75 degrees, and the red LED will turn on for any error greater than 3.75 degrees. These 2 buttons on the right allow me to change the user's desired temperature, and I'm going to use that to model changing my error value to show how the system responds due to different errors. And this button in the top left by the LEDs allows me to initiate a sample step response that drops my desired temperature well below the measured temperature so we can see the introduction of a duty cycle in the form of LEDs lighting up. I'm going to go ahead and begin that step response. As you can see, the LCD shows that. Drops the temperature to 22.5 degrees Celsius. Our error is now about 2 degrees Celsius, and you can see that because we are greater than that 1.25 degree threshold, we've turned on the second green LED. I'm now going to make my error larger to bring my duty cycle up to 100% and show you that even with an error greater than 5 degrees, only the red LED will remain on. So now we've passed the threshold of having an error greater than 2.5 degrees, so the third LED turns on, and we've now passed that 3.75 degree threshold, and even with an error greater than 5 degrees, you can see that all 4 LEDs remain on, and we would still have a duty cycle in that range of 75 to 100%, but it would actually be 100% if we were actually using a fan. Now I'm going to show how the system would settle as the error becomes smaller, and I'll represent that behavior by increasing my desired temperature, bringing the 2 values closer together. So as I increase, we expect to see the red LED turn off when my error is less than 3.75, which is right around there. And as we continue, once the error drops less than 2.5, we expect that yellow LED to turn off right there. And now we will wait for the error to drop below 1.25 degrees, which is right there. And now the system will continue to cool. And the blue LED is off because there is no longer an error. Now, if the desired temperature is higher than the measured temperature, that means that no cooling needs to be done, and our system is in equilibrium. And that represents the simple behavior of that feedback structure where I take my output, compare it with my input, and then have the controller determine or alter its behavior to regulate the system. That concludes this demonstration.